Hello everyone, welcome to AWS Community Day ANZ. Hope you had a great time till now with all the talks. So, coming to my talk, it's going to be about architecting an AWS-backed CICD pipeline with Amazon EKS Cluster as the deployment target. So before moving forward, I'll talk a little bit about myself. So I'm Yashvardhan Kukreja, and I'm a former intern at American Express. I'm also an AWS Certified Solutions Architect Associate. I love cloud, I love DevOps, and I love to spread knowledge through the means of tech blogging, speaking at conferences, and also in my free time, I love to study about quantum mechanics, astrophysics, and I love to run. So, moving on, there's some time for some intro. So today, what are we going to do today? So basically, we will learn about the workflow, about the general ideas towards developing and architecting a CI/CD pipeline for a fully containerized application, which will be eventually deployed on a Kubernetes cluster. And in our case, it's going to be an Amazon EKS cluster. Don't worry, if you feel buzzed out, I'll explain everything throughout the talk, right? Now, moving on to the technologies which we are going to playing around with. First one is our beloved Kubernetes. So Kubernetes is a well-known container orchestrator. So basically the workloads which are deployed on containers, with like the applications which are being performed on containers. So to manage them, to schedule them, to automate the deployment, to even monitor them and even to help in debugging them, this tool is being used, Kubernetes. It's a container orchestrator. It helps like save a lot of menial work and save a lot of time in doing some manual work which can be done in an automated fashion. So that's what Kubernetes is. It orchestrates the containerized workloads and hence it saves the system administrators from pulling their hair. Moving on, Amazon EKS. So see, now as I talked that Kubernetes is an amazing tool to automate the containerized management, the management of containerized workloads. But still, setting up a Kubernetes cluster is in itself is a pretty big task. So to deal with that big task, to make that big task pretty easy, there are services which cloud providers provide to set up Kubernetes cluster in a totally managed way in a matter of few clicks. So Google Cloud Platform has its own equivalent of a service like that. Similarly, Amazon also has its own, and that service is Elastic Kubernetes service. So it is a fully managed Kubernetes service provided by AWS, and it's basically a very convenient way to create and manage clusters in a matter of few clicks. Like there is no need to manually install and configure Kubernetes clusters. That's all going to be done by AWS. You just have to provide some initial configuration and a few clicks. That's it. Moving on, our EC2, probably the most fundamental thing which we are going to deal with AWS. So it's basically a service provided by AWS to host servers and computers on AWS cloud. So the so-called servers, when you host, let's say you are hosting a website, so that website is deployed on AWS. So it must be running on some server on AWS, right? So that server is going to be an Amazon EC2 instance. So basically throughout this talk, if I might say EC2 instance or if I might say server or computer, please consider them synonymous for this talk. So yes, to summarize, Amazon EC2 instance is basically essentially a server or a computer on AWS cloud. And yes, we can access them, we can enter commands, execute commands to them by accessing them as virtual machines from our laptops through the means of SSH. Right? Now moving on, Jenkins. So this is the bell of the wall. So basically Jenkins is a server. It is a tool to create and manage CI/CD pipelines. So everything in a CI/CD pipeline, right? From pulling the code from GitHub to running the tests to making the deployment, everything will be performed by Jenkins. Like this is the entire backbone, the entire body of CI/CD pipeline. Like every entity of the CI/CD pipeline, every stage of our CI/CD pipeline, we will set it up on Jenkins. So I will be showing you how Jenkins looks. It's basically a web app. It's a server. So you run it on a server, and it will be exposed as a web application on some port. So don't worry, I'm going to be showing you how it works. And yes, we are deploying Jenkins on a server, on an EC2 instance, and I'm going to be calling it as a Jenkins server. Okay, moving on. So let's talk about CI/CD pipeline. But before moving on, I would first of all like to quickly mention about what CI/CD is. So basically CI/CD is the process wherein all these stages of testing, like unit testing, integration testing, regression testing, then manual testing also there is there for a code to be deployed. Everything is performed by a CI/CD pipeline. So basically, a CI/CD pipeline automates the entire stages, automates the entire process from the point where a code is pushed till the point the code is finally deployed on a production-based application. Because again, your code is never directly pushed to the production application the moment it's updated. Like there are a lot of stages in middle, right? So to automate those stages, to maintain an automatic workflow for those stages, a CI/CD pipeline is created, and hence it is called continuous integration and continuous deployment. So now moving on. So now basically before creating a CI/CD pipeline, we have to think about it like according to our application, according to the practices we follow in our organization. So for that, it's always good to have an idea. It's always good to demarcate the objectives for the pipeline which we are constructing. So for this application, for this talk, I am focusing on the use case of containerized applications, because these applications are nowadays very general in the market, because most of the applications are microserviced, and microservice applications make use of containers. So from that perspective, I've demarcated these 4 objectives. So the first one should be very obvious one, that the pipeline should be triggered as soon as there is a code change, so that things are real time, right? You don't have to wait for some time for the pipeline to execute the CI/CD workflow for the code. Second is also an obvious one. It should perform testing well enough to make sure the updated code is reliable. Because we can't have blind faith for our code. It can be less performant, so it might fail load tests. It can be buggy in one way that it might fail the unit tests, or it might not well integrate with the other functionalities, so it might fail the integration tests, right? So yes, this CI/CD pipeline should perform testing enough to make sure the code is reliable. The third objective is that the application should be packaged as a Docker image and being shipped. Now see, our application is containerized, so of course our application need to be packaged as a Docker image and shipped to Docker Hub, right? And finally, the final objective is that it should be deployed on a deployment target seamlessly without any downtime. So yes, there are ways to deploy the final application, the newly built image. Now a naive approach is stopping an existing deployment and creating a new one, but that will involve downtime. So there are strategies like rollout is one, wherein there is no downtime involved and your application is being updated seamlessly. So I'll explain and shed light upon it, how it happens. Kubernetes provides capabilities for that as well, to perform that automatically. Cool. So now moving on, based on the objectives of this pipeline, these are the stages which I am going to be including in my pipeline. So the first stage is simple. It's going to be cloning the updated code. So let's say a developer pushes the code, new code. So then the pipeline will be triggered through the means of webhook, and then stage 1, these stages will start executing sequentially, right? So the first stage is going to be cloning the updated code. Second stage is going to be cleaning the existing images, containers and code. So this Jenkins server will be repeatedly running CI/CD pipeline whenever a code updates happens. So there might be a chance that existing images might be running, existing containers, existing code might be there. So just to avoid conflicts, this stage 2 will clean up all these existing stuff just to make sure there are no conflicts. The third stage is going to be building a Docker image for testing. So basically, the code base which I'm going to be showing you, it actually consists of 2 Docker files. So the one Docker file is for building the main application's Docker image. The second Docker file is called dockerfile.dev, which when run will produce an image, and that image can be used for testing. So the stage 3 basically will build the dockerfile.dev and just like call it, let's say, test image. Then stage 4 will run that test Docker image. Now this test Docker image, when it will run, it will execute all the tests associated with it, like unit testing, integration testing, regression testing, load testing, anything. So basically the entire testing workflow is going to be dependent on this test Docker image. Now let's say if the tests pass, then our pipeline is going to move to stage 5, wherein the main application's Docker image is going to be built, right? The main image, not the testing one, the main application. And stage 6 is about pushing that built image for main application to a registry, to a Docker Hub. So Docker Hub is one of the very well-known public registries, and registry is basically like a GitHub equivalent of storing images, Docker images. And we are going to tag it with a new version number, And in our case, the new version number is going to be the build number associated with the CI/CD pipeline. So whenever a CI/CD pipeline runs, there is a build number which all like every time new pipeline is run, it increments. So this new version number is going to be associated with the build number of the corresponding CI/CD pipeline which got executed. And finally, the stage 7 is going to be making sure that on the provisioning server. So the provisioning server is a server which will be the point of contact with the Kubernetes cluster. So the stage 7, the Jenkins will basically, trigger provisioning server to talk to EKS cluster to update its image, to update its deployment, because this new Docker image got pushed to Docker Hub, right? So a new application essentially got pushed. So this provisioning server will tell EKS that, dude, new application update is there, so time to update your deployment, right? So that's gonna happen. So I hope I'm clear, and if I'm not, then no worries. I'm going to be just moving on to the practical aspects, right? So this is the usualized workflow. This is what exactly I just explained, so you can later on check it out on the slide itself. It's just a visual representation of what I just explained about these stages. So time to dive into it, right? So before diving into it, I'll just show you the application which I'm using as an example for this CI/CD. So it's a basic Node.js application which has a base route, and this base route returns two things: a success key with a boolean variable which is true, and a message key with a string value which is something like welcome to the AWS community day, something new, something way more cool, right? And the testing is being performed by this file called tests.js, and it is performing very simple unit testing. It is just checking that the response of that route we created, right? In that response, the success key is having a boolean value and the message key is having a string value. That's it. So right now it will pass successfully because again we have constructed in this way. So I hope you got it. And apart from that, there's a deployment.yaml file. So this is the recipe for Kubernetes to make the deployment. So this will be run by the Amazon EKS cluster, right? The provisioning server will tell Amazon EKS cluster to run this YAML file, and the EKS cluster will run this YAML file to make the whole deployment. And finally, the cleanup shell script is there. So this cleanup is the one which will be used in the stage 2 to perform the cleanups. And finally, there is a deploy.shell script, deploy.sh. So this is going to be the one which the provisioning server will execute in the stage 7, right? The final stage of deployment. So every time the stage 7 gets executed, the deployment server or the provisioning server will execute this stage, right? And basically with this script, it's pulling the rightful things to talk to the EKS cluster and make the deployment. So pretty simple, right? And here's the Docker file for building the main image, and here's the Docker file.dev for building test image. Both of them are essentially same, only the last command is different. So the last command for testing one, the Docker file.dev is npm test, and for Docker file, the main one is npm start. So I hope that is clear. Now moving on, I'll just show you the list of EC2 instances. So here is my EC2 console, and here is the provisioning server. I'll go to the Jenkins server, and this is the IP. And okay, I've just opened it. So you can see that in this IP at port number 8080, this is your Jenkins dashboard, right? It is just like a web app. It's being running on the the Jenkins server at port number 8080. So if I go to the configuration of the pipeline, so it has all those 7 stages, and the pipeline script, the main recipe behind setting up all those 7 stages. It's extremely simple and quick to code. So yeah, here it is. See, I hope it's visible. And if you see here, so it's the syntaxes are pretty basic and pretty descriptive. So you can see that this is the first stage, cloning the repository. This is the second stage for performing the cleanup. This is the third stage for building the test Docker file. And they're bare commands, right? The commands for the command which you will execute in your own computer. So yes, this is what is exactly simple. So you can have a look on them. So by the way, I'm going to be providing the link to the repository. So the repository will have all these resources so you can feel free to check them out and help yourself. So moving on, so basically this is the basic gist, and here I check this option of GitHub hook trigger. So whenever a GitHub hook happens, right, a GitHub push happens, so there is a thing called webhook with which Jenkins will be notified that, dude, a code has been updated, so time to run the pipeline. Cool. So yeah, so I've saved this, and also my local host, right? My local terminal. Actually, my local host is actually configured with an AWS user. So like if I show you, so I'll just show you this. I just ran this command. Just a second. Yeah. So these are the user related details which are associated with my local host. So with this user, I created the EKS cluster on the AWS console. So technically my local host, this user is the owner of the cluster. So I can talk to it right now. And if I talk to it, I can actually show you by running the kubectl commands to show that already right now the service is being exposed on Kubernetes. Okay, it got ran. So here is the URL to the exposed load balancer on which the cluster is running. So if I paste it and run it, beautiful. So it works, right? Now I'll show you something really cool. So I'll just manually, like with my own intentions, mess up the application and just push it to GitHub, right? So this will basically, ideally it should fail, right? So I'll just zoom in it a bit. And now see, you remember now the test was basically checking that the success key is a boolean variable and the message key is the string variable. So just to make it fail, I'll change the success key to a string variable from a boolean variable, right? And now if I push it, I'll just commit it. Test push, I'll call it. Put push master. Now ideally the test should fail, and we can actually look at the CI/CD workflow. So see, it got pushed. Now I'll just quickly hop onto the pipeline and just look at it carefully. Yeah, see, automatically this 11th build got triggered, and this 11 you're looking at it, right? This is the build number associated. And also the Docker Hub this is the repository wherein all the versions of your images are going to be there. So with every successful build of the pipeline, a version of Docker image will be pushed to Docker Hub. So now see, beautiful. So it failed, and yes, it failed because we can actually have a look at the logs as well. So see, expected this string, right? The string literal I wrote to be a boolean. So that's what tests are saying, that they were expecting the success key to be a boolean, but all they got was a string. So that's why it gave an error. So now to fix it as a very responsible developer, I'll just change it back to true, basically a boolean variable, so that it will pass the tests. Now again test push and git push origin master, and it should work right now. Okay, let's see. There should be 12th build triggered by now, and here it got triggered. Beautiful. So it's where it is. Yeah, here it is. So the first two states pass successfully, and now the testing state should also pass. Let's wait and watch. Beautiful. So see, the test passed successfully. So now the main Docker file the main Docker image was built, and now it's pushing to Docker Hub, and it's finally making the deployment. Now while it makes the deployment, we can actually go to the Docker Hub and refresh it. And remember the version number, it should be tagged with, yeah, remember about it. So it's going to be the build number associated with the pipeline. So the pipeline execution here, the build number is 12. So the version number of the newly pushed image should be 12 as well. So just it's refreshing. See, beautiful. A few seconds ago, see, a few seconds ago, and here is the 12th version number. Perfect. And basically we are saving this version number in the CI/CD pipeline in the environment variable. So while executing the stage 7 on the provisioning server, we can actually tell provisioning server that the newly deployed image is of version number 12. So tell the EKS cluster to pull that image and deploy it, right? And see, final deployment also succeeded. So now if I go back to my service, see, this was service, right? So if I go back, it should be running fine. So see, it says something new, something way more cool. And just to show that if we successfully make an update to the cluster, then this thing is going to update as well. So right, so now the message was welcome to AWS Community Day, something new, something way more cool. And I'll just change it to something way more cool nice. And I'll just commit it and push it. And I'll just show you how quickly and how seamlessly the deployment happens. This is the last phase of this thing. And meanwhile this thing happens, I'll just tell you that how the so-called seamless deployments happen. So basically I told you about the knife approach, right? That wherein you stop the existing deployment and start a new one. So what happens is that in rollout strategy is one of the strategies where you can make updates seamlessly. So now in a Kubernetes, yes, your containers are the so-called workers, but they reside in a thing called pods, Kubernetes pods. So pods are the true workers in a Kubernetes cluster. So now right now the cluster I have in it, 4 pods are running, okay? So the load is getting balanced between 4 pods and stuff, okay? So now whenever an update happens, right? So instead of just dropping the 4 pods and starting the, new 4 pods, that's going to involve downtime. So what Kubernetes I have configured it to be is that it's going to perform a rollout wherein instead of suddenly dropping 4 pods, it's going to drop 1 pod out of the 4 old pods and start a new pod, right? So now you will have 3 old pods and 1 new pod. Then it will stop another old pod and it will start a new pod. So now you will have 2 old pods and 2 new pods, and it will do it again. It will stop 1 old pod and start a new pod, and it will have 3 new pods and 1 remaining old pod, and finally it's going to stop 1 old pod and start a new old pod. And at the end you will be left with all the 4 new pods with the new piece of code running. And see, at any point of time there were at least 1 or 2 pods which were running, so there was no downtime associated. So that is the basically idea of performing seamless deployments. Now the deployment also succeeded as expected, and now if I go and refresh this thing, let's see what happens. Sorry, my internet is a bit slow. Yep, beautiful. See, something new, something way more cool and way more nice. Yeah. So basically, yes, this thing got updated successfully. So that was the practical aspect of it, and I'm going to be posting all these resources on the repository so you can have a look at them. Now moving back to the presentation. So now the question comes up that is this the only way to architect a CI/CD pipeline? Well, think about it. Okay, I'll just cut it short. So the answer is no. As I told you, CI/CD pipeline is something which is extremely dependent on the type of application you are facing and the kind of DevOps practices being followed by organization, right? So see, if you look at this current example of the practical thing which I showed you right now, it was a fully containerized application. So the CI/CD pipeline involved a lot of stages dedicated towards containers, right? Like pushing to Docker Hub, building an image. But what if your application is not containerized? It doesn't follow the containerized architecture. Then it's going to be having a different sets of stages, right? Like that stages might be involving some different kinds of mechanisms. Similarly, let's say you have a machine learning based application. So in that, the CI/CD pipeline for that will involve stages dedicated for building machine learning models and training models, right? So that is going to be different. And let's say another example is, let's say that you have an application which focuses on security audits a lot. Or let's say your organization follows DevSecOps practice, which a lot of organizations are doing now. So that kind of CI/CD pipeline will involve multiple security, audits, multiple stages for performing security checks, right? So and for the performing security checks, there's a tool, Trivi, which actually is a vulnerability scanner, so to check the vulnerability associated with the image. I actually work on this open source thing, so do check it out. It's a lovely tool. So basically, I could have something like, before pushing to Docker Hub, I could have a stage where Trivi could actually check that whether my newly built image is very vulnerable or not. And if it's vulnerable, then don't push it to Docker Hub and send a mail to the team that's saying that, okay, the newly built Docker image is very insecure and vulnerable, so we are not the image is not being pushed to Docker Hub. So the team will be notified, right? So yes, basically the answer is that no. The CI/CD pipeline is like there is no CI/CD pipeline perfect for all the applications. There is no one way of developing a CI/CD pipeline, right? There are 1001 ways to do so. And finally, CI/CD possibilities are endless. Even the technology you use for CI/CD pipelines, that depends a lot on your applications. So my usually take on this is that, let's say you have a application which is fully deployed in Kubernetes, just like the one which we dealt with. We can actually use Jenkins X for it. So with Jenkins X, whatever I did, right, the whole 7 stages and all that can be compressed into one stage. So Jenkins X is a fantastic tool. You can always check it out. Also, if let's say you have an application which is entirely deployed on AWS, totally on AWS cloud, then AWS Code Pipeline can be a lovely tool for using for implementing CI/CD. Apart from that, if you have simple projects and if you have projects which are deployed a lot on GitHub and they deal with basically the focus towards GitHub, then you can have Circle CI, Travis CI. GitHub Actions is a fantastic CI/CD technology which came by GitHub last year. So yeah, the list goes on. And even for performing deployment, you don't need to rely completely on Jenkins. There are technologies, there are tools which are dedicated to ease the deployment process. There is a thing called Octo Deploy. So right now in this talk, I showed you how Jenkins is also talking to provisioning server and deploying this thing, right? So instead of doing this thing manually, you can use a thing like Octo Deploy, which will perform this whole work on its own. And you will have to just configure a bunch of things for the first time. So possibilities are endless. Do check them out. And I believe that CI/CD are probably the best pieces of technology to get a feel of DevOps. So yeah, do check them out. So well, that's it, I guess. Thank you so much for reaching till here. And I would love to connect with you guys on Twitter. Do follow me on Twitter, on GitHub, LinkedIn, on Medium. I write tech blogs. So do check them out. And thank you so much for reaching till here. And all the resources for you, all the resources, codes, links, everything is at this GitHub URL, Yashvardhan Kukreja AWS Community Day Talk. Do check it out. And thank you so much for this. Thank you so much for listening to my talk.